Okay, 10-4 outliers. So we're going to talk about data points that are far away from the rest of the data. Okay, so students at Waldo High School are involved in a special project that involves communicating with people in Kenya. Consider the box plot of the ages of 200 randomly selected people from Kenya. So here's the box plot. You can kind of see the lowest age is a little over 0. And then we've got the box area, and then we've got our whisker, and then we've got these 4 points out here. These are what we consider typically outliers, or points away from the rest. So a data distribution may contain extreme data, specific values that are unusually large or unusually small relative to the median and interquartile range. A box plot can be used to display extreme data values that are identified as outliers. Each asterisk in the box plot represents the age of 4 people from the sample. Based on the sample, these 4 ages were considered outliers. Okay, so this is 4 different people they sampled that are way older than the general data. An outlier is defined to be any data that value is more than 1.5 times the IQR away from the nearest quartile. What is the median age of the samples from Kenya? So I kind of marked in here on my approximate, if I read this down, it crosses right before 20. So I said that was 19. So we're going to say the median is 19. Okay, and it says, what is the approximate values of Q1? So Q1, we're going to say, is 9. And Q3, which if I read it down, I said is approximately 32. Okay, and then it says, what is the approximate IQR? The IQR is the length of the box. It's called the interquartile range. If you think this little whisker is 1/4, this is 1/4, this is 1/4 of the data, and all this is 1/4. Then the inter 2 quarters, so the interquarters are this box. And how long is that? What is the range of that? 32 minus 9 or 23 is the IQR. Okay. So then it says multiply the IQR by 1.5. So 23 times 1.5 is 34.5. Okay, so this is considered the how you find the data, okay, the outliers. So 34.5. So IQR is 23. 34.5 is 1.5 times the IQR. Okay, and then if we turn to the next page, it says add 1.5 times the IQR, which the data we just got was 34.5. We're going to add that to Q3, which was 32. So 32 plus 34.5 is 66.5. So if we look at 66.5, which would be somewhere in here, what do you notice about the 4 points here? It says, do you notice that they are all larger than the outlier? So the outlier is really the tip of this point. Okay, so what do you notice about the 4 ages? They are all greater than 66.5. Okay, so when you're figuring out an outlier, you find the length of the box, multiply it by 1.5, and then you add that to Q3. So you add it, you need to be more than that distance away. So 34.5 this way or 34.5 this way. So you need to be up by 34.5 or down by 34.5 to be considered an outlier. So in this case, going up would make it 66.5. Okay, so anything greater would be an outlier. If we go down, which is the next part, it says, are there any values that are Q1? Q1 is 9 minus the IQR, the difference here, which is 34.5. And 9 minus 34.5 is negative 25.5. So if we go over here, we'd be way over at negative 25.5. And that's probably impossible since this is ages of people. So it says, are there any age values that are less than that value? And if these would be these considered. So there are none, because you can't have negative age. However, they would be considered outliers if they existed. Okay, so they would be outliers if they existed. And it says, explain why there is no asterisk on the low side of the box plots for ages, and that's what we were just talking about. Okay, you cannot have negative age. So the low end puts the age into negative 25.5, which is not possible. So that's how you find an outlier, okay? So you find the length of the box, multiply it by 1.5. You add that to Q3 to find the high end of the outliers, and you subtract it from Q1 to find the low end. Anything outside, so anything in this range here, anything over in this section here, are considered outliers. Anything in between would be normal data points.